Welcome to Conceptual Learning, where we explore mind-bending ideas that challenge our understanding of the world. Today, we're blasting off into space to explore a theory that's truly out of this world. Panspermia, the idea that life on Earth might have come from outer space. Imagine this. Billions of years ago, our young Earth was barren and lifeless. Then, a comet or asteroid comes hurtling through space carrying tiny stowaways, microscopic life forms. These cosmic travelers crash land on our planet and voila! Life on Earth begins. Sounds like science fiction, right? Well, welcome to the world of panspermia. Panspermia comes from the Greek words pan, meaning all, and sperma, meaning seed. It's the hypothesis that life exists throughout the universe, distributed by meteoroids, asteroids, comets, and even spacecraft. But before we dive deeper, let's get one thing straight. Panspermia doesn't try to explain how life originated. It's more about how life could spread through the cosmos. Think of it as a galactic version of Johnny Appleseed. But instead of apples, we're talking about microbes. Now, you might be thinking, hold on a second, space is harsh. How could any life survive out there? And you'd be right to ask. Space is a pretty inhospitable place, with extreme temperatures, vacuum conditions, and deadly radiation. But here's where it gets interesting. Some microorganisms on Earth are incredibly resilient. These extremophiles can survive in conditions that would kill most life forms. Take tardigrades, for example. These microscopic water bears can survive extreme temperatures, radiation, and even the vacuum of space. In 2007, some tardigrades were exposed to open space for 10 days. Many of them survived and even produced viable offspring after returning to Earth. If life on Earth can be this tough, who's to say that microbial life forms couldn't survive a journey through space? But the journey is just the beginning. To support panspermia, these cosmic travelers would need to survive entering a planet's atmosphere and the impact of landing. Then, they'd have to adapt to their new environment and begin reproducing. It's a long shot, but some scientists argue it's not impossible. In fact, there's some evidence that makes panspermia more than just a wild idea. First, we found organic compounds in meteorites. The Murchison meteorite, which fell in Australia in 1969, contains over 14,000 organic compounds, including amino acids, the building blocks of proteins. Secondly, we've discovered that there are more planets out there than we ever imagined. The Kepler Space Telescope has found thousands of exoplanets, many in the habitable zone where liquid water could exist. Lastly, we know that material can travel between planets. We found rocks on Earth that came from Mars, ejected by asteroid impacts and eventually captured by Earth's gravity. All of this doesn't prove panspermia, but it does show that the basic requirements for the theory are possible. Now, let's look at some variations of the panspermia hypothesis. 1. Lithopanspermia. This is the idea that rocks ejected from a planet by an impact could carry microorganisms to another planet. 2. Radiopanspermia. This suggests that the pressure of radiation from stars could propel microorganisms through space. 3. Directed panspermia. This is the hypothesis that life could have been intentionally spread by an advanced extraterrestrial civilization. That last one might sound a bit out there, but it was actually proposed by Francis Crick, one of the co-discoverers of DNA structure. Talk about thinking outside the box. So, what do critics say about panspermia? Well, the main criticism is that it doesn't solve the problem of how life originated. It just moves the problem to another planet or to space itself. Also, while we know some microbes can survive in space-like conditions for a while, we don't have evidence of any surviving the thousands or millions of years it would take to travel between star systems. Despite these criticisms, panspermia remains an active area of research. Scientists are studying how microorganisms behave in space, analysing meteorites for signs of life, and even considering how we might accidentally spread Earth life to other planets through our space exploration efforts. So what can we learn from the panspermia hypothesis? First, it reminds us that the origin and spread of life is still a mystery with many unanswered questions. Secondly, it highlights the interconnectedness of our universe. The same physical laws apply everywhere, and matter, possibly including life, can travel vast distances. Lastly, it encourages us to think big. Really big. Universe big. And isn't that what science is all about? Whether or not life on Earth came from space, the Panspermia hypothesis expands our horizons and reminds us that when it comes to life in the universe, the only limit is our imagination. So what do you think? Are we all aliens? Did life on Earth hitch a ride on a cosmic taxi? Let us know in the comments below. If this video sparked your curiosity about life in the cosmos, don't forget to like, subscribe and hit that notification bell for more mind-expanding content. Remember, here at Conceptual Learning, we're always ready to launch your mind into orbit with big ideas. Until next time, keep questioning, keep learning, and keep looking up at the stars. Who knows, you might just spot the next delivery of cosmic life coming our way.